Hey everyone, how's it going? We're going to be learning the fundamentals of Autograd today. This is the, I think, well, what is Autograd? Isn't it? From my understanding, I thought it was an additional special capability that allowed you to assign, this might be different, a dedicated learning rate per weight in the model. So that way you could more dynamically train each of the model's weights. However, I don't think that's what that is. I think this is something different. And we're going to learn about that together here. We're going to see what this is all about. All right, 1 second. Pytorch Autograd. Done. All right. So Pytorch Autograd feature is part of what makes Pytorch flexible and fast for building machine learning projects. So wait, it's just the graph? Is that all that is? It's the ability to connect all the elements together and make it really easy for back propagation? Is that what that is? Hey, Jinlu, good to see you. This is a certified internet two-way radio classic. It sure is, yeah. Kyle inspired us to play this song first. And Jinlu, you're here, you're early. You're here early. It's great to see you. Hope you're doing okay. What we do is we do this song first. And then we go to this song, right? You know, this song right here. And then we head on over to the YouTube studio play mix. The YouTube studio. That's what we do. All right. Yeah. All right. Nice. Good to hear it. Pytorch Autograd allows for the rapid and easy computation of multiple partial derivatives, also referred to as the gradients over complex computations. Okay. So it's just Pytorch. Is that right? Is that what I'm saying here? This is the foundation of Pytorch. That's what Autograd is. That's what that is. That's all that is. Automatic gradient. Really? I feel like I've been misled here to believe this is something way more advanced than it is, because I've done this many times myself. Personally, I've done this by hand. And so it feels like this was some advanced capability. This operation is centered to back propagation-based neural network learning. All right, well, fine. Really? I was like all excited. I'm like, we're going to learn something new and fancy today, aren't we? We're going to learn something new and fancy. Pytorch Autograd. It's the new thing that you never... Yo, how's it going there, developer Exotic? Good to see you. Welcome on in. We're going to learn Pytorch Autograd today, although it turns out that is just Pytorch. As far as I'm understanding it here, that's just straight up Pytorch. I built this myself, too. We did it live on stream. We did this live on stream from scratch without a framework. The power of Autograd comes from the fact that it traces your computation dynamically at runtime. Does it really though? Does it? Meaning that if your model has decision branches or loops whose lengths are not known until runtime, the computation will still be traced correctly. Oh, okay. Well, I see some maybe potential scenarios where like maybe you have filters in a CNN or filters in a transformer with a QKV. Hey Torva, good to see you. Hello, welcome on in. Happy Tuesday. We're learning Pytorch Autograd today. And you'll get correct gradients to drive learning. All right, well, it's just repeating the same thing. All right, this combined with the fact that your models are built in Python offers a far more flexibility than frameworks that rely on static analysis of more rigidly structured model for computing gradients. I don't know about that. This is some, what is this called? Some gloating? Is this boasting? Are they bragging right here? They're like, Pytorch is so good. It's better than all the other rigidly structured model. Those more static analysis of more rigidly structured ones. All right, Pytorch is dynamic and fancy. You're gonna get a better result with Pytorch. What do we need for Autograd? A machine learning model is a function with inputs and outputs. For the discussion, we'll treat the inputs as an I-dimensional vector, x. Okay, so x, of course, right? Multi-dimensional with element xi, okay, with elements of xi. We can then express the model, m, all right, model's gonna be m, as a vector valued function of the input. Okay, so why so early these days? I know! Watching while on break, I'm gonna get, gonna go about 20 minutes. We're early these days because we have a bunch of meetings that kind of block out the whole day. So this is the only time we can make it work. Otherwise, we would have to not do stream for 2 weeks. He's got a lot of meetings this week. Yeah, exactly. They're all like back to back. So There's no chance for even a smidgen of a stream otherwise, right? And I'd rather stream earlier. All right, so m is going to be the model as a vector valued function of the input y. Well, x is the input, y is the output. This is always confusing to me. Like, why do they invert it? I want it to be m of x and then y is the output. His schedule is packed. There is even a chance for lunch. Oh, exactly. Right? I'll sneak it in, though. Don't worry. I'll sneak in lunch. We can't skip that. We treat the value of m's output as a vector because, in general, a model may have any number of outputs. Of course, you can have as many numbers you want. As many as you want. Since we mostly be discussing Autograd in the context of training, our output of interest will be the model's loss. Will it, though? L. Well, only if you calculate L. You can't calculate L unless you know what Y is supposed to be. Speaking of lunch, check general chat. Did you do lunch or dinner? Is it lunch or dinner? It's probably dinner, right? General. What do you got over here? Ooh! It looks like some sort of meat pocket. It looks like a meat pocket of some sort. Is that egg? Is that egg? With corn? I can't tell. Corn and beans and zucchini. That's what it looks like. What is Autograd? Hey, how's it going there? Autograd is apparently just Pytorch. Is what it is. Apparently, it's the main feature of Py. I didn't know that, so I've written my own Autograd before. I didn't realize that it was this. Essentially, it's a way that makes Pytorch what Pytorch is. It will track all of your connected layers and activations, essentially all your functions. It merges together, and then we'll also have derivatives for back propagation when it goes backwards. If it's a layer that it has a derivative, it can apply the derivative. That's what it's still lunch technically. All right, got it. I guess I'll mostly be watching the VODs this week. All right, Torva, sounds good. All right, good to still have you here though. It's a wrap made with zucchini, carrots, egg, and bind together, so it's filled with a salsa and some meat. A meat wrap with egg, zucchini, and carrots. That sounds great. You eat pretty good. Also, kidney beans in the yeah, I saw that. I saw some kidney beans right there. Very nice. Very nice. That's awesome. For me, I would eat just the kidney beans, the zucchini, and the carrot. That's what I'd eat. Okay. You also had a great lunch today. Oh, nice. I'll post it in general. Sounds good, Torva. I'm actually kind of curious about that. I'm super curious. Okay, let's check it out. Single value vector scale function of the model's output. This function expresses how far off our model's prediction was. Only if you have the answers, which are not represented here. They're not represented here. It would be nice if they were, though. This function expresses how far off our model's predictions was from particular inputs. Ideal output. The ideal output. Do you think it's worth learning C++? I think it's okay to learn C++. I think if you're going to be learning, it depends on what your objectives are. Are you making a AAA game, maybe running it in Unreal? C++ is great for that, right? Because you're going to be building AAA games with C++. Are you going to be building some extremely high performant something? Doesn't matter what it is. Then you probably would rather learn Rust. Because Rust is type safe, concurrency safe, and memory safe. So it's got 3 things that goes for it. C has some of those things built in. You still can make mistakes. And you have to rely on other people's libraries as well that have potential mistakes in them. That's why Rust would be better for basically everything else other than C++. That's what we did at my company. We migrated all of our C over to Rust. We are very close to 100% Rust. We're not there yet, but we are very close. This year, 2026, 100% Rust. If you want to learn C for like algorithmic purposes, I recommend just learning C. You don't need C++. How's it going there, Mark Lemon? Good to see you. Thank you for saying hi. Welcome on in. If you're making an operating system, C or Rust. There you go, Jinlo. Excellent. Yeah, it depends on what your objective is, because C is a tool, right? So you want to use the right tool for the job because there's different tools for different scenarios. At this point, we will often omit the vector sign where it should be contextually clear Y instead of Y vector. Oh, sure. Okay. So that's fine. I mean, I kind of, why not just keep it? Why? After this point, we'll often omit the vector sign where it should be contextually clear that it is. It is clear. It's just pick one and stick with it. We don't need it both ways. Hey, Claude, good to see you. Hello, man. Welcome on in. Happy Tuesday. The training model, we want to minimize the loss. In the idealized case of a perfect model, this means that adjusting the learning weights, that is, the adjustable parameters of the function, such as the loss is 0 for all the inputs. You want a 0 loss for 100% perfection. However, do you really want that? Yes, I kind of do. I want perfection. The point of AI is to give you correct answers on data it's never seen before. So if you train it on data and give it 100% perfection, which you can do, you can actually achieve this. You will miss out on potentially generalizing enough to allow it to predict correctly on data it's never seen before. In the real world, that means an iterative process of nudging the learning weights until we see that there is a tolerable loss for a wide variety of inputs. Tolerable loss. What is that? It's low enough that we are able to make good, accurate predictions. Yeah, just evaluate the best language for your project and then whether you need to learn it and what the advantages is of using a language you already know. Exactly, because it's going to take you more time and effort to learn the new language. Are you really going to get what you need from that? I recommend learning every language if you get a chance to. Every language is eventually the same. They all have iterations, expressions, flow control, some sort of structured component to it, like organizing code, modules, classes, objects, things like that. Oh, and my lunch is in general. All right, let's check that out real quick. What do you got over here? Ooh, you're fancy. Is that really your lunch? There's like truffle on there. That's truffle. Are you Torva? Who are you? Who are you? If this real, this looks like stock photography. Really? You need to put like today's newspaper in it. Like, you've got some basil, you've got some ricotta, some prosciutto, some truffles. Are you kidding me? Some truffles? Torva is secretly Jeff Bezos. I know, right? Who are you? Did you hear that Meta's shutting down the metaverse, by the way? I heard that they said they were and they took it back. I heard they took it back. Hey, Quantified Quantum, good to see you. Hey, Steven, welcome on in. Good to have you here. Happy Tuesday. Quantified Quantum, I hope you're doing okay. Hope everything is working out the way you need it to. Hope the best. Is there lunch live you made, Torva? It looks like Torva made lunch with truffles and prosciutto. That's crazy. You already ate it, but I have some more pictures. Do you? You get proof. Yeah, proof. I got it. Okay. It was worth taking photos over. All right. Hey, Steven. Hey, study channel 40,053. Welcome on in. Happy Tuesday. Good to have you here. We're learning Pytorch Autograd, which apparently is just Pytorch. I thought it's like the fundamental layer of Pytorch. It's the whole thing. I thought it was going to be something fancy. We're learning Autograd. Nope, you're just learning regular Pytorch today. But we'll walk through it anyway, because we want to learn everything. No stone unturned. We're going through every tutorial because we're going to become Pytorch experts. All right. So, in training a model, we want to minimize the loss. Idealized case of perfect model means that adjusting learning weights, I think we already read this, is adjustable parameters of the function, such that the loss is 0. Right. We want to iterate and nudge the weights until they're a tolerable loss. How do we decide how far in which direction to nudge those weights, though? We want to minimize the loss. We want to reduce it to 0, which means making its first derivative with respect to the input equal to 0, something L equal to 0. Okay. The output into 0. Okay. So, some L. I don't know what L is. It's some variable. You're going to have to fix the Bluetooth config on your laptop because the PS4 controller works over cable, not on Bluetooth. It's so nice when it works on Bluetooth, right? It's so good. You ate out and it's not that expensive. You know where to eat the pizza. Got it. It was 16 euros. Was that euros? Okay. All right. Recall, though, that the loss is not directly derived from the input, but a function of the model's output, which is the function of the model input directly. Right. Okay. Oh, is L loss? By the chain rule of differential calculus, we have 16 euros. It has truffles. That's crazy. It is. It's pretty crazy. So the loss of the y vector over some... What is that? What symbol is this? What is this? This is called a partial derivative operator. Oh, no way. That's what that is. It's a partial derivative operator. All right. How's it going there? Manihara Narki. Wait, listen, I'm gonna pronounce your name. Hey, how's it going? 1 second. Manihara Nchari. Manihara Nchari. All right, I gotta give it a shot. It's good to have you here. Thank you for joining on in. Happy Tuesday. We're learning Pytorch Autograd today. So this pretty symbol right here means partial derivative operator. Neat. Okay, learning more. The more we know, you guys, the more we know. The internet is best. Free college. Yeah, exactly. Free college, so we don't need a degree. You don't. Proof is in the stream. Teaches a lot. Yep, exactly. No sugarcoating. No needed. Exactly. All right. Partial derivative of mx, partial derivative of x over m is where the things get complex, though. Uh-oh, we've got some complex scenarios here. Got some complex scenarios, you guys. All right. The partial derivatives of the model's output with respect to its inputs. If we were to explain the expression using the chain rule, it would involve many local partial derivatives. Hey, how's it going there? Clinker Plays 101. Thank you for the 100. TensorFlow versus Pytorch. Who's going to win? Who's going to win? I don't know. I would say right now it's Pytorch, right? Even though TensorFlow from Google, and Google I think is probably in the premiere of all the AI right now. They're in the premiere of all the AI. Thank you very much, Clinker Plays. That is fantastic. I appreciate it so much. At Clinker Plays. All right. Thank you, exclamation point party popper. Appreciate it. That is very nice of you to do. Thank you. Wait, did that go through? Oh, all right, good. It went through. All right. Thank you so much, Clinker Plays. I would say PyTorch. Right now, obviously, we're learning PyTorch. And it's a little more straightforward in some cases. However, TensorFlow with Keras is easier to use. I think it's easier to use. Used to talk smack about Gemini. Now you feel like it's gotten better than GPT. Oh, yeah. It's doing good. It's doing good. You know, you haven't been keeping up with AI much? Has Google abandoned TensorFlow? Because they are on JAX now, right? Yes, it may be because of JAX. Now we've got JAX, you guys. We've got JAX now, which we'll probably maybe consider learning after TensorFlow or after Torch. Hey, how's it going there? Hadar, how's it going, Hadar? Steven, I have a question. How many hours of learning I need to reach level I can make AI like ChatGPT or Manus? Thank you for the effort. Valuable channel. Oh, you're welcome. Yeah. It might take a smidgen. It might take a smidgen, maybe a couple months if you're really dedicated. If you're really dedicated. For me, I'm only spending a couple of hours a day. What is JAX? Oh, it's like PyTorch, except for Google. It's the Google's answer to PyTorch is what that is. Study channel. Stephen is a data science aspiration of compulsory to learn deep advanced math, statistics, linear algebra, and calculus, or is basic enough? For data science, basic is mostly enough. Because you're going to be doing simple things in data science. It depends on how far you go. If you're doing business data analysis, you won't necessarily need to enter too far into like the side of regressions, right? You can do aggregations, transformations, and you're good. And there's higher level notations that help you get through that. Something like SQL, right? SQL, very heavy in the data science world. Makes it really easy for you to manipulate large volumes of data into the right shape that you're looking for. I love it. A framework or something. Exactly. JAX is a framework. Hey, how's it going over there? Vibe Havkarathi? Yeah, I tried to say your name there. Good to welcome on in. Happy to have you here. Anytime you hear JAX, I have to think of a character that's amazing digital circus. Is it? Wait, I don't know what you're talking about. What is that? JAX. JAX is the Google's answer to PyTorch. I think that's what that is. Gemini better than, don't know what they but GPT hallucinated way more than the previous version. At least it seems to be to you, Torva. So GPT, yeah, there was a lot of hallucinations, wasn't there? It's getting better now. They're doing better. You're working on an AI agent security domain. It's a very niche domain, and quite a handful are working on it. Well, thank you for creating the agents for security. We need that. We need that very much because we need the defense. Because there's a lot of attackers out there using AI to attack us. Wouldn't it be great if we had defenders? And you're helping us out. You're helping us out. Appreciate it, Clanker Plays. It's theory time. So what if Multiverse is Stephen, a founder of robotics and tech? Oh, I thought about that. We might not be done yet. There might be more to it. Look up The Amazing Digital Circus on Google. All right, The Amazing Digital Circus. What do we got here? Oh, it's a TV show. Oh, neat. Oh, it's on Netflix. Okay. Do we have some detail? Psychological dark comedy about cute cartoon characters who hate their lives and want to leave. Okay, we'll have to maybe watch that at some point. Hey, Drawing Brothers, good to see you. Welcome on in. Mohammed, welcome on in. Thank you for saying hi. Good to have you here. O4 Many hallucinates 46% of its answers. Ooh, that's a lot of hallucinations. Facing the context rot of the MCP tools. That is a lot of context rot. That is, you got to make sure that your context is tiny. Make it small. Small context. Your current focus on more enterprise right now. You know, security is always afterthought. It is, sure is, isn't it? Always the afterthought. Thank you for doing it, though. My guess you're almost got it right. Almost always. Just short of perfect. Just short of perfect. You can watch it for free on YouTube as well. Oh, nice. Okay. I've got Netflix. Thanks, Stephen. Secondly, I'm from data science, analytics background. Nice. I have about that Python. Nice is most widely used, but for learning data structures and algorithms, can you do it with Python? Yes, you can do it with Python. Absolutely. 100% you can do it with Python. You'll get more out of it if you learn it with C, I would say. You can do the same thing in Python. No problem. You absolutely could. CLI versus MCP tools. What should we do? Both. You need both. MCP is just a way to more interactively interact with a large language model that gives it access to some sort of programmatic system that's more hard-coded. It's nice because it's more of a plugin. CLI, CLI, I don't know how to say that. You could use CLI, MCP, there's totally different things. They're very different things. CLI has less context rot. What do you mean? What do you mean by that? Partial derivatives are my distant cousins. Are they, Clankers? Are they? Well, we're doing some partial derivatives today. That's the plan. We're doing Autograd, you guys. How to become a full stack developer, like YouTube courses or anything. Have not much time, in your opinion. My recommendation is go through a tutorial. Just go through like a deep tutorial once and get the foundation of the basics and then start building something with it. Like go through a deep tutorial, like a MERN stack, MERN stack tutorial for full stack dev. That's my recommendation. You made a web server from scratch, Drawing Brothers in C, decreasing performance and factor to serve files directly without copying the memory. That was so fun. Nice. So you took the direct file descriptor from the operating system for the file, and then you passed the bits or the bytes over to the network file descriptor without any memory. Thank you, man. Sorry I have to leave. All right, sounds good, Claude. Good to have you here. Almost 2, but almost streams live. Meet you tomorrow. See you tomorrow then. You were in my feed because Amazing Digital Circus fandom or AI just developer circle. I don't know why. You just happen to pop on in. Good to have you here though. What do you think about AGI, artificial general intelligence, and where we are in reaching a conscious AI? I don't think we have a conscious AI yet. We don't have something that's alive. We have a giant statistical math equation. That's what we got right now. A super large math equation that is able to, well, what is a human though? Are we similar? I don't know. I don't know. Any tutorial suggestions? I do not have any tutorial suggestions. I recommend going out and finding one that looks attractive. There's a bunch. Just go to Google, MERN stack tutorial, and it will auto-correct it for me. There is a AWS web developer training. That sounds okay, though you'll need to spin up some servers. MERN stack developer, Udemy. That costs money. Hey, Ivan Serenico, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. There's a MERN stack course right here for 3 hours if you want to sit through that on YouTube. There's a bunch of options. I just say do MERN stack tutorial, and then you'll be full stack. There's a library by Hong Kong University people. They are migrating the things back from MCP to CLI. Naming was CLI anything. Well, you could do that too. That's perfectly fine. I mean, it's not like you're changing much. You're not changing much at all by doing that. You still have function calling and tool use. And whether you directly embed it in the CLI or you call out to an MCP, it's the same thing. It doesn't really matter. You know, my deepest, darkest desire is to do machine learning using x86 assembly. Clinker plate. You want to do that? You can do that. You just need to do some matrix multiplication and some derivatives and some math in assembly. If you want to do that, you could. You could do that. If you want. Morning, friends. Bon Zoopy, good to see you. Welcome on in. Happy to have you here. You recommend doing some front end first? It'll be, oh, right, good point. So front end, HTML, JavaScript, CSS. Good point. Then switch to back end because you have to learn a lot in the back end, like DSA, databases. Front end, you just use the output immediately. That's a good point, Drawing Brothers. If you want to do full stack, you also need the front end, HTML, JavaScript, CSS, maybe a framework, Svelte, Vue, React, right? Those sorts of things. If you're talking about like web-based or Kotlin or Swift for mobile, that works too. Study channel, thank you, Stephen, for the reply. Also looking forward to the end of the deep learning. Me too. Gen AI projects from your side. Yes, we're going to be building like our own transformer. We'll build our own transformer, you guys. We'll make it happen. We'll build our own GPT. Really excited for it when we'll be, yeah, that's going to be a lot of fun. I'm excited. It'll happen. It'll happen. Can we connect on LinkedIn? Absolutely. Tell me when you're ready and tell me when you're ready. Say, hey, I just sent you a request and I'll click the go button. I'll click the go button when you're ready. When you're ready, I'll click the go button. Yes, absolutely. Autograd and x86 is gonna be fire. I know, right? That would be a bit much. Anyways, we gotta go, Steven. All right, sounds good. Torva, pleasure. Hope you have a really great rest of your day. You too. React isn't a framework though, isn't it? Wait, Jinlu. Wait, what do you mean it's not a framework? Of course it's what else would you call it? Hey, Swiped Bod, good to see you. Welcome on in. Thanks for the nice message. I just sent the request. All right. Here we go. Zoom out. All right, is that you? All right. It looks like it. Okay, good. Okay, accept. Message. All right. Hi. All right. We're connected. It worked. Hey, Stephen. Hope you're doing well. We're doing great, Levi. Thank you. I'm Pranav Patel. Recently, we got connected on LinkedIn. Oh, Pranav Patel. Yes. Okay. I remember we chatted on LinkedIn. Yes. Study channel. Fantastic. React is a library. Drawing Brothers. Is it though? Wait, is it a library? It's not. So technically it can be a library because you don't need it to be used for everything in your project. Like, for example, isn't Claude using React somehow? The Claude Code CLI? Why would you ever want it, right? I know you don't have to. You can do it. Should you though? No. No, you shouldn't. The React devs keep saying it isn't a framework. Oh, they do? All right, I'm going to still call it a framework. Sorry. It can be used as a framework because it's got so much. It's got so much out there. Hey, how's it going there? The dreaded Karakin. Welcome on in. There's something off here, you guys. Something's off here. Yeah, React is a library next to framework built on top. So something like, what is it? XHTML? Or, right? XHTML? Is that what that is? Right. XHTML. Isn't this it? No. What am I thinking of? Is this it? No. What is the one I'm thinking of? HTML. HTMX is what I'm thinking of. HTMX. That's what I'm thinking of. This is more of a library, right? Because it's not really a full-on framework where it's got everything opinionated defined for you automatically. HTMX, you still have to bring more stuff, right? With React, it kind of gives you a whole ecosystem of everything. Appeared on your machine learning quiz, got a really poor grades. Oh no! Any tips for me now? Studying in regression, stochastic regression? Stochastic just means random, Levi. It just means random. Thank you for the hearts and reactions, guys. Good to have you here. Levi, stochastic is just random. Dude, your ears are huge. Are they? They're fine. Hey, Roy Val. Thank you for your chat message there. Bonzupi, you mean? Oh, mean. Yeah, definitely mean. I know, right? What are you doing over there, Roy Vals? All right, sent a connection. Quite impressive profile. Appreciate it. Sure, you just sent one just now on LinkedIn. All right, so let's go back over here. Right here? Yes, I think right here, right? It's a Manhiharan Chari. Is that right? You say yes? Totally uncalled for. I know, right? Bonzupia. Can you hear the future? I can hear the no, I can hear the past. You're all seeing and hearing the past. We're always like behind by a smidgen. Yes? All right. Send a message. Hi, exclamation point. All right. We're connected now. Alia Faili. Alia Faili. Welcome on in. Hi, man. Thank you. Appreciate it. Welcome on in. Good to have you here. We're doing some partial derivatives, you guys. The partial derivatives of the model's output with respect to its inputs, if we were to expand the expression using the chain rule again, would involve many local partial derivatives over every multiplied learning weight and every reactivation function and every other mathematical transformation in the model. That's a lot, you guys. That's a lot. Steven, can you troll Rust for me? What do you mean troll it? I'm a C++ lover. Oh, well, it's really easy to just yell at the compiler with Rust. It is. It's a rough learning curve. And even when you're using it regularly, Rust is like, nope, you're wrong. Oh, you should try this. You should try this instead. This is what you really meant, right? Okay, fine. That's maybe what I really meant. You copy and paste it. You try again and they're like, nope, that doesn't work either. But you told me it works. Rust compiler, you told me it works. Why are you doing that to me? React doesn't give a full ecosystem. We have to set up the bundler, SSR, Next.js. Oh, got it. Well, I mean, where does a framework end and the library begin? Right? Like, where's that line? Is it fuzzy in the middle? Is it okay to call it a library and a framework at the same time? Because it's in the middle somewhere? I think it might be. By the end of the day, we need to build something quickly. Don't we? We sure do, Brian, brother. You got it. Some excellent videos on partial derivatives. Oh, Bonzupi, yes. 3 blue, 1 brown. Can you explain what PubNub is? 1 billion devices, jaw-dropping, Stephen? Yeah. We are a globally distributed and for communication. We power many use cases and businesses and industries. So live updates, sporting updates, right? Multiplayer games. Let's see, can I zoom out on this? Is this gonna, let me reload this real quick so we can navigate through here. Is that gonna reload? There it goes, okay. So multiplayer gaming, obviously when you have multiple players, you've got people playing like games on their phone or on a computer. They need to connect and communicate their player movements, right? That's what we do. Live auctions and bids, that's what we do. If you place a bid, everyone else needs to see your bid. Financial, stock ticker updates, quotes, metrics, meters, call centers, tickets, support chat. When you're interacting with someone on the internet and you're talking to them, right? Delivery, logistics, and transportation. When a car is moving on the map and you can see them update. Multiplayer, casino, and betting, right? Sports media updates, scores, live chat, all that stuff, you guys. That's what we do. Rust is strict for a good reason. It sure is. It's very strict, you guys. So does that, I think I'm also using PubNub without knowing it. You sure are. Basically, right? By the chances are of the probabilities, everyone's used it by now. What's up? Hey, Anasazi, good to see you. I love it when smart people troll Rust. And There's some things that Rust is get a little strict, yeah. A little strict. I was working on the auto research with Andrei Karpathy on Mac. His 600 lines of code is also giving chills to me. 600. Ooh. Sounds interesting. Hey, Steven, thanks again for yesterday. Hey, you're welcome. Hey, Michael. Yeah, Michael. It was a lot of fun chatting with you. We were discussing potentially some world changes, weren't we? In the interesting direction. When you said that and you mentioned that, I'm like, that can't be right. Is it right? Are you really going to do that? You're serious about it. You're real serious. How do we get into fintech? Well, I recommend, well, it depends on what you mean by fintech. So are you going to try to do quanting? Are you trying to analyze stocks, securities, things like that? Really depends. I think something like why finance is a pretty good way to get into it. Why finance is a good start. I like that. Do not enter it. It's exhaustive. It really is. It's very exhaustive and very nerve-wracking because if you get it wrong, you can lose with consequences. If you get it right, you can do okay. So it's like the get rich quick, right? Get to it quick. I prefer the get rich slow. Let's get rich slow. And it's a trident. You can get it better. All right, let's get back into our Autograd, you guys. Let's get back into Autograd. The full expression for each of the partial derivatives is the sum of the products of the local gradient of every possible path through the computational graph that ends with the variable whose gradients we are trying to measure. That's one ginormous sentence right there. My goodness. Wait, you gotta break that apart for a second. The full expression for each such partial derivative is the sum of the products of the local gradient of every possible path through the computation graph that ends with the variable whose gradient. I am not able to break that down completely. The expression for each partial derivative is the sum of the products of the local gradient. Okay, I get that part. So we get the local gradient that we've derived, that we've applied the partial derivative of every possible path through the computation graph. This every possible path, is that talking about the fully connected layers? Is that what that's talking about? The computation graph that ends with the variable whose gradient we are trying to measure. I heard building fintech software pays well. Oh, yes. You can get a role in fintech. There you go. The quickest way from start to finish. What is, oh, is that what that means? Is that what that's talking about? It's the quickest way from start to finish. Okay. In particular, the gradients over the learning weights are of interest to us. The gradients over the learning weights. Yes, okay. I know that part. I understand that part. That makes sense. I've done that. I understand the gradient part. I've built it before. You think so? All right, good. Michael, thank you. This is really helpful. Fintechs pays well. Your hayline, you're right. Due to stress, exactly. You might have a lot of stress. I'm about to graduate in computer science and engineering by the end of April, and I'm looking forward to doing a master's. Oh no, and see this. All right, computer science engineering in Australia, most probably next year, 2027. February intake. All right. I'm very curious. Are you going to generalize or are you going to specialize? That's my study channel. Are you going to generalize or specialize? They tell us what direction to change each weight. I get this part. This part makes sense. So we just talked about how we calculate the gradients. So we calculate the gradients in reverse. From the loss, calculate the gradient, which gives us the ability to apply a full 100% adjustment to the previous layer. Once we could choose to apply the full extent or apply a learning rate, right? We can do a learning rate on that, which reduces that loss as you apply it to the weights to get the loss function closer to zero. Yes. Okay. I got that part. That part I get. Isn't Y Finance platform, we get data sets for training models. I remember we did something like that. Stock market prediction. Yes, exactly. All right. Apparently, this is a reading stream today. Where's the code at? I want to do the code. Are you learning regression too? Regression? Yes. So regression is a simpler form of a deep learning neural network, right? Regression. Although you can build a deep learning regression model if you want. This is essentially regression. You got it. This is training the model. Since the number of such local derivatives, each corresponding to the separate path through the model's computation graph, will tend to go up exponentially with the depth of the neural network, so does the complexity in computing them. This is where Autograd comes in. This is where the magic Autograd comes in. You're talking transition from data analytics to AI engineer. Nice. 6 to 8 months. Enough to gain some expertise. Yes, absolutely. I am building projects side by side. Nice. You're doing it right, Study Channel. You're doing it right. Good job. Just study regression. The page on your screen seems familiar. This is basically the same as regression. We're just applying it in a larger fashion. In a bigger scenario. More data. Sense something in general. What do you got, Jinla? Ooh. Hey, that's... Wait. Peak retro gaming. That's pretty much, yeah. Obviously, we got Legend of Zelda here. It looks like a... Oh, hey, look, it's me over there. Hey, check that out. I'm reading some Pytorch Autograd, and you're playing Legend of Zelda. It looks like you just started. Well, you got a few more hearts, though. You're talking, but I can't hear because the music is too loud. Oh, that's me talking. That was me talking in the background. Okay. I was like, who? I can hear you talking. No, that was me. I was me because you're listening to the video at the same time. That was awesome. That is a really good game. I love Legend of Zelda. That's awesome. All right, Drawing Brothers, what you got over there? All right, Bun? Yeah, Bun. All right, I know Bun. Bun.js is not a runtime tool like Node.js. It packed with a lot of tools. What are you doing over here? It packed with a lot of tools. Is this not... There's some error. There's a grammar error right here. Immediately, there's a grammar error. In new Bun, developers can run C code. Currently, it doesn't fully support C features like including some of the header files. What is this now? Bindings, TypeScript, and C. Okay, that's pretty nice. Oh, nice. So, all right, foreign function interface. You can import a C. That's pretty neat. Wouldn't you do a header file? My main concern is that it's fine that you have a career gap 6 to 8 months and doing the masters in Australia next year. That's fine. Will the career gap get negative impact? No. I think you're fine. I think you're fine. It might be good to get a job during that time, though. I mean, it's just how long you want to wait until you enter into industry is what it is. Use VRChat as your background environment. Oh, nice. That's awesome. VRChat. Does Pytorch have C++ under the hood? Yes, it does. Levi, yes, it does. Yes, Levi, yes. Yes, Levi, yes. It does. It's called libtorch, which is C++. And we import that into Python. Look at the code. Okay. So we'll do add int. Very simple method there. Import bun foreign function interface. Then we run the add function. So you've got an add symbol, source main, symbols, args, and return. Oh, nice! That's really clean. I really like that. Oh, I like that a lot. The only thing is you want to be careful. You don't want to keep calling that function because you're not actually going to get a performance boost due to FFI. Call expense. That translation layer is expensive. Why does Atom work better than SGD here? Oh, the stochastic gradient descent? Well, Atom is going to give you an acceleration on the initial epochs, right? Atom is initial epochs. All right, so let's see here. All right, Gemini. Okay, so Atom versus SGD. Atom has faster, higher initial learning rate and adjusted learning rate. Because there's also momentum in SGD. SGD has momentum learning rate. You can do it however you want. There's nothing. This is all math. It is fully customizable. It's fully customizable, you guys. That was your blog. Oh, new to blogging. I've got something. One sec. In comparison between Atom and SGD, stochastic gradient descent, SGD typically requires a significantly higher initially learning rate than Atom. However, Atom adjusts the learning rate for every single parameter in your model. Whereas standard gradient descent, standard stochastic gradient uses the same rate for everything. There we go. That's what Atom is. It adjusts the learning rate for every single parameter in your model. That's what Atom is. That's why it's better. Because it can help reduce those vanishing gradients and exploding gradients and get you to the answer of a better loss earlier with lower hardware requirements. That's why Atom, you guys. That's why Atom. Is learning C easier for one who already knows C++? Yeah, it is. It's way easier. If you already know C++, you already know C. You just have to forget a few things because it's not available in C. I'm doing an internship. All right, that's great. Internship, yeah, 15th of June this year, although you've been hired for data science role. Hey, they're giving you tasks on unit tests and Django backend. Study channel, you are amazing. You're at the top, 1% right now. Hey, Beanos, good to see it. No, Steven, don't use the AI. I know, right? Well, I'm using the AI to give you here's what I do. I give you my answer first, and then we confirm it. We confirm it, right? That's what we do. We ask Steven the question, and I'll be like, I'm going to prove that I'm right. And I go to the AI, and the AI says, yeah, you're right. So that's what we do, you guys. That's what we do. Startups make you work random problems. They sure do, right? Don't they? Math is part of coding, mostly written like you're doing a novel. Anasazi, every day, all the time, right? If you know C++, you technically know C. You sure do. Drawing Brothers, you have a grammar error. Where is that at? Where was that at? Where did we put that? Did we lose it? Where'd it go? Where'd your blog go? Was it here? Here it is. It packed with a lot of tools. You need to say it is packed. So that would be it is packed. Grammar error right here. This is my favorite part. Drawing Brothers, I like this. This part right here is my favorite. I love it. I know exactly what's going on there. That's why I like it. I can read that. C++ is a superset of C. Exactly. All C code is valid C++, right? It is. It sure is. Best advice is build. If you're going to go to school for computer science, just build something over and over. Just do it. Exactly. Anasazi. Best advice. Best advice. All right. I need to check my calendar real quick. Make sure we are on time. And then we'll get back to our objectives. Yes. All right. Perfect. 40 minutes. We are good to go. Good to have you guys here today. Best advice. Yep, you got it. Why is learning rate important in the training model? Is it something to do with compute cost? Yes. So you want to be able to converge on the minimum loss early. You want to minimize your loss as soon as possible. You want to minimize that loss. Get to the lowest loss possible. Early as possible. Otherwise, that means that your model's not learning and you're wasting time on you, because it's the same level of compute cost, whether you learn quickly or learn slowly. Every iteration is the same. So you want to minimize the number of iterations. And that's why you want to have a high learning rate. However, if your learning rate is too high, then your model is going to collapse. It'll collapse on itself. All the weights will either explode or shrink. They'll vanish. So you gotta be careful. You gotta tune it just right. Got to tune it just right. It's very delicate. Thank you for the hearts, you guys. I'll let it pass this time. Beanos. All right, sounds good. Yeah. All right, thank you for the pass. Let's see. Recently, you have started work with data science. All right, nice. I don't know. We can auto commit the weights to Git. You can if you want. Just make sure they're not too big because Git has a maximum file size. I'm not sure it's either 5 gigabytes or 50 gigabytes. I think it's 50 gigabytes. If it's bigger than that, you have to use some sort of large object thing. I think Bun.js will be the future of development. It's pretty good. It's pretty good. The creator of Linux prefers C over C++. Me too. I like C. I don't want to touch C++. I like C or Rust. C or Rust, you guys. All right. All right, you guys. Cool. C or Rust. All right. C, Rust. Which one's better? Which one do you like better, you guys? Curious about that. Proof of concept available for CVE. Oh, wait. Oh, hey, Radhard. Radhard, what are you talking about? CVE. Uh-oh, we got some vulnerabilities, you guys. Hello from South Africa. Iron Fist Programming. Welcome on in. Good to see ya. Hope you're having a great Tuesday. Hope you're having a great Tuesday. No worries. All right. Bun is acquired by Anthropic. Oh, that's right. They did. They bought Bun, which is weird. Remember they bought that? Remember that? Copyright music. All right. Next song. 1 second. We're flipping over the next song. 1 second. There. Let's do this one instead. Okay. Right. Click. There we go. Okay. We'll have to reload that. 1 second. That one. Okay. All right. Thank you, Jinlo. Appreciate it. Bro, can you teach math and machine learning? Absolutely. That's what we're doing on this channel. We're going to be becoming Pytorch experts. We are learning everything that we can from Pytorch. We've written our own AI frameworks before in the past live on this channel in Rust and Python. We've done it. It worked. It worked. It worked really well. Pytorch version before 2.6.0. Oh, is it? Wait. There's a CVE for Pytorch? Let me look that up. Really? C4 for Pytorch? TuxCare. Oh, let's see here. It is. It's Pytorch. All right. Sorry for the blinding white screen, you guys. We are looking into a CVE. This CVE has been updated. Zoom in so you can see what's going on here. Pytorch is a Python package that provides tensor computations with strong GPU acceleration and deep neural networks. Yep, blah, blah, blah. Based on Autograd system, which is what we're learning today. In version 2.5.1 and prior, a remote command execution RCE vulnerability exists in Pytorch when loading models. Yes, this is why we use safe tensors, you guys. Use the safe tensor. Use safe tensor. Use safe tensors. Otherwise, remote command execution can happen. They can take over everything. You can build anything if you have a PC and C. About everything. You sure can. Isn't that great? Isn't that exciting? You are the wizards of the world. C. Wow. I did not think C would get 80%, you guys. I did not. Why isn't Rust up there at number 1? Why aren't you clicking Rust? Rust would be the answer. This is a real mood change. It is a smidgen. Yep, you got it. The epic YouTube studio music. After your internship, you'll also be preparing for IELTS. Part of learning AI and building some stuff. Oh, study channel. You're like on top of this. You're like going all the way. You're like holding back nothing. That's great. Bunzupi, I don't like the poll. You can't make me choose. All right, Bunzupi, no worries. No worries. You don't have to choose. You don't have to. What is your favorite though? Which one's your favorite? You don't have to choose. You don't have to tell me, but one of them's going to be your favorite. What do you think apart from the US, which countries are good at machine learning? Let's see. I mean, obviously China, right? Though they are, well, it is it's US and China, isn't it? Then you've got India and what is it? What is that? French model, Mistral. And you got Mistral. And then a couple of German ones. That's it. Everything else is US or China. I didn't like you don't like both. Oh, you didn't both. You like both. Oh, got it, Bonzupi, got it. I like both too. How old is it? How old is what? Oh, this vulnerability? Let's find out. Where's the date? There's got to be a date in here somewhere. Okay, here we go. Last year. Okay. So it's a year old. It's a year old. All right. Y'all, we don't have to worry about this too much. We're good to go. We're on pretty good versions of Pytorch. Okay. Every time I've written Rust, my chair broke. I know, Jinlu, right? It's always the case. Mistral Uncensored. Hey, there you go. XD. Mistral Uncensored XD. You sure could do that. That is a strong one. XD. I like that. I haven't seen XD in a long time, you guys. I haven't seen XD in a long time. You meant C. C is great. I like C. I like C a lot, too. I use C. You don't like Rust? Oh, Levi, you don't like Rust? One of my Rust developer friends rizzed my crush with his Rust skills. Yeah. I can see what you're doing over there. Rust is a way to go. It can do some really powerful things. You rather dislike C++, I'll say that much. Yeah, me too, Bonzupi. You and I are on the same page here. C++ has a bunch of unnecessary things in it that have been built, according to the author, for job security. That was why they added complexity. The ability to have extra packaging and wrap. Sounds kind of nice for that level of container. When you have code that's easy to encapsulate and then transport. I don't care, though. I don't care that much. Namespaces. It's all about namespaces. I see a lot of XDs. There are a lot of... Oh, yeah, the smiley cat face. I always think that's a smiley cat face. Oop, not that one. There we go. All right. Let's get back to our tutorial, you guys. Let's do more Autograd. We got 30 minutes. This is where Autograd comes in. It tracks the history of every computation. Every computed tensor in your Pytorch model carries a history of its input tensors and the functions used to create it. I know this part. I built this live on stream. We did this last year. Lots of C++ adds new features every new update. That is, yeah. So that is one thing. So C++, it's got a lot of users. It's also Unreal framework language of choice. So if you're building a AAA game, you're using Unreal Engine, then you're going to be using C++. So there's a lot of C++ out there. There really is. Combined with that fact that Pytorch functions meant to act on tensors each have a built-in implementation for computing their own derivatives. Yeah, I built that before. We did that. This is greatly speeds the computation of the local derivatives needed for learning. It makes it super easy. I've even done GPU kernels that merge automatically the activation and derivatives inside the kernel. It does. Isn't Pytorch built in C++? Yeah, it sure is, Bonzupi. It sure is. It is, yes. Yes, it is. It is, yeah, exactly. To use Raylib 2, though technically that's regular C. Raylib is regular C, is it? Okay, that sounds nice. Can a C developer hack into NASA? Oh, Levi! Wait, hold on. Only certain people have asked that question on this channel. Who are you, Levi? Are you someone that we know? Bonzupi, it's unfortunate. Unfortunate, sure, right? But we don't have to deal with it, right? Someone else is dealing with it. Someone else is dealing with it for us. If C++ extensions for C, why have C#? C# is a whole different language, right? C# is more of like Microsoft's answer to Oracle's Java. I like C# better than Java. C# is a little bit less verbose, and it gives you some extra goodnesses. I like it. C#'s fine. C#'s great. Java, I don't want to have to anymore. Also, C#'s more efficient. It's faster. C# is more like Java than it is like C. Exactly, Bonzupi. C# is sharper. It sure is. Let's go through a simple example, you guys. That's what a lot of theory. Let's see what it looks like in Autograd in practice. Let's get our terminal open. Finally, after a full 60 minutes, we're now on to some actual code. Forget I ever said anything about hacking NASA. Okay. We'll send beat. Okay, got it. All right, no worries, Levi. Thank you, Stephen, for your replies. Need to leave for dinner. Sounds good, study channel. Thank you for stopping by. Good to have you here. Catch you next time. We'll be back tomorrow. Let's start with a straightforward example. First, we'll do some imports. Let's get our graph results. Okay, so torch, and we're gonna plot some plotting things. Okay, and then math. Why do we need math for? Oh, we're using pi. All right, so we need the constant. I haven't learned C#. Is it worth to learn? It's worth to learn if you want to get into the .NET world of Microsoft and Windows. That's when it's worth to learn, I think. You build a game with C#, it's fun. Nice! Did you use DirectX? Did you use OpenGL? Or did you use a game engine with C#? All right, you guys, let's get into it. Let's start. Let's pull it open. Let's pull open our code editor. Here we go. All right, close that. All right, ls. Okay, so this will be vim agrad.py import torch import matplotlib. What are we doing? .pyplot as plt. Import matplotlib.ticker. Import math. There we go. I made a game in Visual Basic once. A few here may know. All right, yep, VB. VB is awesome. I remember VB. That was my high school. VB was in high school. So in high school for me, it was Visual Basic, PHP, and JavaScript. That was high school for me. Those are my high school. But C++ was my very first language. That was before high school. Ticker as ticker. Oh, thank you. Hey, someone Bonzupi. Thank you for paying attention. Nice little fix there. Appreciate it. Is anyone interested in OCaml nowadays? My Russian friends love it. Let's take a look at OCaml syntax really quick. OCaml syntax example. All right, let's take a look. Just to see what we got going on here. All right, look at some OCaml. All right. What is the modulus operator, % operator doing right there? Why is that? m.b? Yo, I'm looking at some beautiful colors here. I don't know what's happening. I get this part. Let b equals bar in let x. What is happening here? This is like a functional language, isn't it? Geez, I haven't heard of OCaml in years. Bonzupi, I know, right? It's been a long time. Why did they have to... Other function, arg. Okay, so this is a function. So this is a very, very functional language. So you define variables as functions. Match, and you've got your matches, and you've got your output. What's M and B? I don't know what M and B is. I don't. There you go. If you want some OCaml, there's some OCaml, you guys. Let me zoom in on that real quick. Nope. Oh, no. Where'd that go? Oh, it went away. Oh, well, whatever. Okay. So many colors. It was great. When I first opened OCaml, I was confused. There's a lot of pretty colors. I think it's pretty. And then you look at this right here, and it's like, okay, that's pretty dull. Comparatively. Next, we'll create an input tensor full of eventually spaced values on the interval. So that would be between 0 and 2 pi. And specifically requires grad true, like most functions that create tensors. Torch line space. Lin space accepts an optional requires grad option. Setting this flag means that in every computation that follows, Autograd will be accumulating the history of the computation of the output and the tensors in the computation. Yes, I do that. I've done that before. You always accumulate the history of the output. You got to do that. And you want to save the inputs as well. So then you can create your gradients, right? You got to create your gradients. Who here remembers fruit? Wait, hold on. What is that? Frutiger air. I don't know what that is. I have no idea what that is. All right. Let's get another poll going in here. What is that, Jinlu? I have no idea what that is. Bonzupi? Okay, I have to look this up. If Bonzupi knows. 1 second. All right, what is this? Art feature optimistic themes of technology in harmony with nature. What? I have to have had run into this at some point. What is this? All right, let's open up some Wikipedia here. Dark mode, thank you. Okay. All right. Frutiger is a design style that prevailed from the mid-2000s to the early 10,000s. All right. Originated in user interface design, later influenced by various other media. It was named 2017 Sofaizan of Consumer Aesthetics Research Institute. Oh, okay. The internet aesthetic. Becoming popular with Gen Z as an object of nostalgia. So wait. I just see a bunch of boxes and some pretty, like, drop shadows. I see some drop shadows. Windows 7 was... It was in Windows 7? It was Windows XP. Windows 7 had the arrow. Oh, the arrow UI! Oh, yes! Okay, yes. I remember that. That was... I didn't run that operating system. I saw it, though, and I thought it was really pretty. Steven, can you show your workspace tour real quick if camera setup is non-static? Camera setup is pretty static, though I think we had it on here somewhere. I'll have to find it. Was it in link share? It'll probably take a while. Is there a way to look at all the images? Let me see if I can find it. I'll have to scroll for a second here. Let's see if I can find it. Is it around here somewhere? Is it here? Is it going to be here? There's just so many things that happen. Where are we at? Are we going to find it? No. I'm going to see if I can find it. Scroll. It's somewhere in Discord. You'll have to find it. It's in Discord. Look for all the images. We've been through a lot of stuff, you guys. This is crazy. Oh, if Torva was here, I bought this game. Yesterday. Anyway, check general as well. All right. You can use filters to the search bar at the top right of Discord. Okay. Let's do search. Includes images. Okay. Let's see if we can find it. Next. Images. Is it in general? All right, we'll try next. It might take a while. Hey, it's Jinlu! Oh, I found it. Okay, here you go. There you go. All right, you guys got it. There you go. That only took like 2 minutes. There you go. There's the workspace. Jinlu, thank you. We found it. Jinlu helped us find it. Are you going to try and build things like RAG pipeline later on after you're done with machine learning? Yes, we're going to be building some pretty amazing things. We're going to be building our own transformer. We're going to be building our own GPT. We'll be building basically whatever we want. I think we can do a RAG pipeline. RAG pipeline is actually pretty straightforward. That's sick. Yeah, that's this place right here. This place. That's this microphone right here. And yeah, you can see it. See, he's got the little spindly thing right there. Yep. And I've got like this neat little stand that holds the phone, which I really like. I didn't think I was gonna like it because I want my desk to be perfectly empty and clear. Like I don't want anything touching the desk, and I want 100% desk access. Check the video you just posted in general. All right, Jinlu, we'll check it out. Here, let me close this. All right. What you got going over there, Jinlu? It looks like you're entering into some sort of store. I like the fish. I like the fish. The aquarium. Whoa, neat. What is this? Oh, Arrow World on VR chat. Fruitiger Arrow World on VR chat. The tricky part with RAG is the embedding. Does your company use RAG for file management and stuff? So it depends what you're using your embedding for, right? You could do similarity search and you want to have an indexing system. You want to have an indexing system with your RAG, so your vectors. Yes, you didn't make this world. Oh, you didn't make this world. Got it. Okay. Game. Yes, Levi. Yes, Jinlu is a game dev. All right, let's get back into our map here. So yes, all right, SVR NAC, yes. So we do not need a RAG the way traditional with embedding. So you could build a RAG without any vector embedding at all. You can use traditional reverse indexing, reverse keyword indexing. You can do that. You can totally do that. In fact, you want to do that. You want to do full text indexing. That is going to give you a better result typically. Right? It is. It's going to work. And if you want, hey, Tom Hawk, good to see you. Welcome on in. Good to have you here. Oh, what's up, Cactus? Oh, Cactus. Wait, who's Air Cactus? Wait, how do you guys know each other? Have you used that big model GPT has on Ugging Face? GPT OSS? Yep, I have. Something like that. It's a long name. GPT OSS. That's it. Open source software. GPT open source software is what it stands for. Yeah, I have. Being a game dev seems like a tough task, tougher than quant dev at least. Yeah, game dev is the most challenging thing because you have only so much compute and you need to be able to render something beautiful on the screen that's engaging to the user. Not only do you need to be good at design, game design, pretty, graphics, there's a lot to it. A lot to it. You only have so much compute and you need to make the screen look very busy. Air Cactus used to be in a team with you. Oh, no way! We made operating system mock-ups. Hey, that's awesome. That's fantastic. That's great to have you. Wow, no way. That's pretty neat. That is pretty neat. All right, let me get back over to our tutorial here. All right, so let's do a line space. All right, so we're going to do this. We're going to create a line space. All right, A equals lin space, right? Lin space 0. We're gonna do a 0 to 2 times math.py, right? All right, because we remember we read it up here, so that is the range. Steps 25. Steps equals 25. Requires grad equals true. Okay, did I get all that? Yep, we got it all. All right. Print A. What do we got? Oh, no, not that one. We went the Python Agrad. Okay, what do we got? No module match plot. Did I spell it right? There we go. Missing decimal. Oh, do we need the, thank you. All right, there you go. Got the decimal. Thank you, Bonzupi. Every detail counts, you guys. Every detail counts. And all that has to be rendered at 60 frames per second. Exactly. Air Cactus, you're welcome. It's great to have you here. What do you think we'll see, GTA 6 or... Oh, GTA 6 for sure. Which one of them we'll see first? Nobody wants World War. Nobody wants that. We want isolated, targeted war, apparently. Let me try and find a screenshot of the mock-ups. All right, Jinlu, sounds good. Hey, Bonzubi, thank you for the correction. All right, so we've got it looks like a one-dimensional array. So a vector that is 25 elements. It said steps. Can we do 2 steps? Let's try that. Yes, okay. So that's 25 elements. Okay. and that is it looks like a sine wave. So does it go, it goes from 0 up to, oh, and it keeps going up. So this is a line that goes up. This is a line that goes upward, okay. Output, yep, looks good. Next, oh, we'll perform a computation on plot. Okay, and then we're gonna do a sine wave. Before we do the sine wave, let's see, A detached, B detached. Oh, right, okay. So A and B, so we need an X and Y. So we'll watch it. PLT dot plot, A dot detach, A dot detach, so we can see what that looks like. Do we need to do PLT dot show? I think we gotta do this. Hey, how's it going over there? Kumail, how's it going, Steven? Oh, how are you? We're doing good, inspired by you. Thank you. That's great feedback. I'm also exploring Pytorch from docs. Hey, nice. We're gonna become Pytorch experts. Let's make it happen. We'll become the best in Pytorch, you guys. The best in Pytorch. Do regular expressions support Unicode characters such as Japanese characters? Yes. Yes, they do, Drawing Brothers. They sure do. I've done this before. Absolutely. How are American kids making an entire operating system Linux-based? Every time you open a LinkedIn, there's a European or American kid making terminal or something of sorts. I know, right? Levi, they're doing all these amazing, crazy things. Kids these days, right? Kids these days, they're going crazy. Building amazing things. All right, this should draw a line. We should see a line here. All right. Yep, that's a line right there. Isn't that exciting? We got a line. I do believe we can do, so B equals torch.sine A, and then we just do B here. That'll draw us a nice pretty sine wave. Shouldn't it? Okay, we gotta do torch. There we go. Correct spelling. Pretty sine wave right there, you guys. Pretty sine wave. FOMO? Really? Oh, no, you're in FOMO? Hey, you can do it too. I mean, no time. Right? Yeah, Bonzupi, exactly. For the torch sin, right? This torch sin. Kids these days are going crazy. They sure are. Trotch. Yeah, I know, right? Trotch. Whoops. I like those typos. Check generally posted a mock-up. Ooh. Very nice. Hey, it's Jin Lu. I see Jin Lu right there. All right, we got a bunch of pretty pictures and a gallery. Oh, very nice. You got your application bar there. A mock-up you made in collaboration with Air Cactus. Oh, nice! Okay. Very clean, easy to see, minimize, maximize, close. Hey, very nice. It's very clean. I like that. That would be a wonderful experience to run on that. All right, we got 10 minutes, you guys. Let's see how far we can get in Autograd. Let's have a closer look at the tensor B. We print it. We see that it has a computation history. Oh, does it? Does it have a computation history? It does. It has a computation history with A, right? Print B. Let's take a look. All right. Let's hide A. So right here is the answer. Oh, right there. Right here, you guys. Gradient. Sine backwards. Right there. Right here. Right there, you guys. It's an older mock-up. The AI automates better. Oh, does it, Anasazi? Wait. It's an older mock-up too. You should have newer ones. Oh, you do. Nice. Jinlu is European. Dude who gives FOMO. Oh, yeah. I know. Fear of missing out. You know what? You can not miss out if you just, jump into it right now. You can just not miss out if you want. Any tricks to get the AI to automate better? Yes. All right. So Anasazi, are you using function calling tool use? At Anasazi, are you using function calling and tool use? That's the way to do it. Okay, 1 second, you guys. Alarm's going off. I gotta, this is the oven. This is the oven alarm. Nothing crazy. The vegetables are ready. BRB. All right, that was it. Broccoli out of the oven, nice and good. Yeah, just do things and stuff happens and you won't miss out. Yeah, exactly. It's like you don't have to miss out. All right, so you notice that we got a history right here. We got some history. Right here, you guys, right here. Sine backward. All right, some derivatives. Got some derivatives there. Right, gradient function. This grad function gives us a hint that we execute the back propagation step and we'll compute the gradients using this sine backward 0 derivative. We'll need to compute the derivative of sine. Yeah, right there for all its tensors inputs. Exactly. Hey Siri. Oh yeah. No Siri, don't do that. No Siri, don't do that. Let's perform some more computations. All right. All right. C equals B times 2. Is that all we did? You can do 2 times B. Print C. All right, let's take a look at what that. This is the Autograd part. Mult backward. So we got a multiplication. So it means that we're going to do a division, right? To derive it. So the division by 2. D plus. Oh, let's do a D. D equals B. Can we do C? C plus 1. Print D. We're learning Autograd, you guys. We're learning Autograd. Check this out. Add backward. Yep. So then we do a subtract. So we can derive. We can derive it, you guys. Wait, are we back to Python 101? Oh, Bonzupi. It looks like we are. However, what we're doing is we're understanding the fundamentals of what Pytorch is. The Autograd. It's all about Autograd. The ability to track all changes in a graph and compute backward. Because we store all the outputs and the inputs and the operations, so that way we can calculate the derivatives. That's all that means. It doesn't sound more fancy than that. Math, I know, right? Math. Math is sad face, I know. That's what AI is, you guys. That's what math is. I like your happy face there, Levi. Someone look at you. Look at that room. What room? Imagine we had a comment reader on. Wait, what do you mean comment reader? Oh, yes, like text to speech. Text to speech. We could do that. We might set that up someday. We should probably do that. We should do text to speech. I love what you're doing. Still feel like I'm learning a Mandarin blindfolded. Hey, it's okay. That's how it starts. All you got to do is just get a familiarity with things. Understanding comes later. No need to understand now. All right, 5 minutes, you guys. It's good. It's doing good with functioning tool use. It has 24 hours or longer or until job's done. Yet wants to talk to you. Not often, but still. So it sounds like you're using a coding agent on Asazi, right? You're using a coding agent. Hey, Fantasticals, good to see you. Thank you for saying hi. Thank you for clicking that little button right there that says hello. Appreciate it, Fantasticals. Good to have you here. Happy Tuesday. On Asazi, are you using a coding agent? What you're going to want to do is ask the coding agent to write you a brand new agent from scratch using function calling and tool use. And then you will use that function calling and tool use agent to run whatever task you're looking to automate. And it will continue forever without being interrupted. That's how you do that. Quick question. Is that what video game designers use? Math? Oh, video game designers, yes. In some cases, yes. They will use common math functions like this to do, so you can draw circles and effects. It's like sine and cosine. Cosine, right? Sine and cosine will be able to draw circles on the screen. Sometimes I get so mad, there's no control. That is a common. Grab a bat, I don't know. Here we go. Okay. It's very common. So yes, exactly, Anasazi. Yeah. Okay. So We've got 4 minutes left, you guys. Then we got to head out. We're going to see what else we got. All right, so let's run that. All right, so we did. So as you can see, we've got various backward derivatives here. What happens if we do more than one operation? What happens if we do more than one operation? I'm actually kind of curious about that. Are we skipping ahead in the tutorial? Let's do 2 times plus 1. What are we going to see here at D? It just says add. Okay. Shouldn't it be an array? It should be array. Use math functions to do animations in 3GS. Oh, yeah, 3GS. Very nice. WebGL, you guys. You pulled up a newer design in the headset. It's a bit scuffed because of the Quest web browser. What is this, bro? Hey, Indie Cry Devil. Welcome on in. We're becoming Pytorch experts. We're walking through Autograd right now, which is the core capability of Pytorch. Pytorch is a framework that allows you to build machine learning models for AI applications. You want to build something like ChatGPT? Well, you're going to use Pytorch, right? Build something like Gemini or Claude or Opus. Pytorch is a way to do that. Although this is the way to do it from scratch, you might not want to do that because it's going to be a lot. Check general. All right, you guys, we're at the very end. Oh, hey, look at that. An upgrade. Oh, you got a desktop management system. Oh, wait, yeah. Is that what that is? Oh, no. Okay, got it. Oh, I see what you're doing here. This is like a bunch of widgets. Nice. You got some note takers. Neat. What is this? What's this cactus? Oh, hey, that's cactus. You're talking about cactus. Okay. Hey, Oleg, good to see you. Thank you for clicking the hi button there. Welcome on in. We got a couple minutes left here, you guys, and we got to wrap up. This is nice. Jinlu and Yig Jinder. Wait, what is... Oh, is this like a jumping rope? I just created an X account. How do I get more followers? Well, you just find the top trend. All right, so there's a couple tricks. All right, so social media, pretty easy. What you're going to do is you're going to find the top, like a really prominent publisher who has a lot of followers, and you'll monitor their account. Wait for them to tweet something, right, or make a post. Be the first commenter. If you're not the first commenter, be the first commenter on the first comment, right? And do the same thing for the top comments. So you can keep doing that. That'll give you exposure. Also, you want your posts to match whatever target audience you're looking for. Make sure it's a vertical. You got to target a very specific audience. Be controversial. Exactly. You want to, what is it called? Polarize your audience. You could draw on it and move windows and stuff. Oh, nice. Indie Cry Devil using a tensor and matplotlib torch. Pytorch using for finding Christoph's symbols and Raman tensors in physics. I don't know. It works for creating AI too. Oh yeah, it sure does. It sure does. All right, you guys, it was so much fun. We're going to continue our Autograd adventure tomorrow with backpropagation. That'll be the plan for tomorrow. Be back tomorrow. We're going to become Pytorch experts. We'll continue our Autograd Part 2. Autograd Part 2 tomorrow, you guys. Thank you so much for joining. We'll be back tomorrow. Appreciate it. See you guys. Bye for now. Bye, everybody. All right, see you tomorrow. Sounds good, Jinlu. See everybody. Seeing Drawing Brothers, Oleg, Anasazi, Indie Cry. We've got DGA, Levi, Fantasticals, and Bonzupi, thank you for the corrections as well. Air Cactus. All right, you guys. Good to see you. Bye tomorrow. I'll watch tomorrow. Sounds good. All right, see you guys.